Our second function, they are directly next to each other, so this makes this one a little bit of fun. We get to multiply. And because we have multiple terms, we can FOIL this if we want to. We can also use the box method. It does turn into a bigger box method question, though, because we have 3 terms to deal with. So 3x squared, x and minus 3, and then 2x and minus 1. So I should do each of these one box at a time. And then here, identifying like terms does take just an extra moment longer. So we have green like terms and yellow like terms put together. And there we go. That is the result of multiplying. For our last one here, we want to be careful with what this is. This is not a multiplication sign. That is a composite function. So this is g of f of x. So first we want to write down what g of x is, which is 2x minus 1. And then inside of where the x goes, that's where we're going to plug in f. So distribute in anything on the outside of the parentheses. And then any like terms go together. And that is it for our first question. For our second one, we are just looking at f of g of x, and we want to also make sure that we state the domain. So starting off with f of x first. So a big set of parentheses, and then inside of that, we can put in our value for g. So using our properties of square roots and squares, what we see here is that our square root actually cancels out, so we're left with just 3 minus x. So to be clear, if you square a square root, those two things cancel each other out. So 3 minus x is our first term, and we still have plus 2. So we end up with minus x plus 5 as our answer here. And the one thing that we want to be careful of is before this is squared, we have to make sure that we're taking the domain from this step, not from our final step. So while it is good, we can cancel some things out. Before we cancel them out, we still have to plug in that x value into the function. So in this step, we have to make sure that 3 minus x is greater than or equal to 0 to make sure that the inside, right here, the inside of our root is positive or equal to 0. So for this, a couple different ways that we can approach it. If we just move the x over to the other side, we can say that our domain is x is less than or equal to positive 3. So anything other than that is going to mean that we don't have a real number there. And again, I just added x to both sides to get that answer. So that's it for the study guide. If you got questions, let us know, but hopefully this helped and you are ready for the skill check.